Hello everyone, so I'm back again with more programming problems. So today, I will be showing you about breathe first traversal in graph. I have here a full code and then we will try to break it down and explain each of the flow of our code, and let's try to analyze how we got the output. Let's start. So breadth first traversal in a graph specifically refers to the strategy of systematically exploring the graph by visiting all vertices at the current level before moving on to the next level. This exploration is typically done using a queue data structure to keep track of the vertices to be visited. So let us now move on to our code. So we will start by creating a graph class with an adjacency list to represent our undirected graph. It's like a map where each node is a key and its neighbor are stored in a list. We then create a new graph constructor and setting up an empty hash map where we will initialize our adjacency list. So let's move on, and now we have here our add node method. So this method ensures that we don't duplicate any nodes. In here, we are checking if the node is not already in our adjacency list, and if it's not there, it means we're about to add a new node. We put the new node in our adjacency list as a key, and the corresponding value is an empty array list. We will now move to our add edge method. We have to check first if both nodes exist in our graph using add node before creating an edge. This ensures we don't miss any nodes in our graph. We then grab the array list associated with each node and add the opposite node to it. It's like we're introducing two nodes to each other. These two methods ensures our graph stays organized and each node is well acquainted with its neighbors. These methods are the one who ensures that our graph stays organized and each node is well acquainted with its neighbors. Now let's move to our brief first traversal method. In here, we will be exploring the graph starting from a given node. But before setting off, we make sure that the starting node is actually part of our graph. And if it's not, we will then print out a warning saying that the starting node is not on our graph. We create three data structures: visited to keep track of the visited nodes, result to store the traversal order, and queue to plan our exploration. We then add the starting node to our queue, making it as the initial point for exploration. We then add a loop that continues as long as there is nodes in our queue. We take the front node from the queue for exploration in this iteration. We then have to verify if we visited the current node before proceeding with exploration. If the node is new to us, we mark it as a visited and document it on our result list. We can now start to explore the neighbors of the current node, iterating through its adjacency list. For each neighbor, if it hasn't been visited, we enqueue it for further exploration in the next iteration. After exploration, we check if all nodes have been visited. If not, we throw an exception indicating a disconnected graph. And lastly, we conclude our traversal by returning the list of nodes visited in order they were explored. We now create a new instance of our graph class, which sets up an empty graph for us. We then add edges to our graph to create connections between nodes. It's like drawing lines on our graph paper. We are now linking nodes. 1 to 2, 1 to 3, 2 to 4, and 3 to 5. We will now initiate a breadth first traversal starting from node 1 and print the result. It's like we are setting off an exploration from node 1 and showcasing the order in which we visited nodes. We will try to introduce two new nodes, 6 and 7. They aren't connected to the existing nodes, creating a disconnected portion in our graph. Now we will try to perform a brief first traversal starting from node 6. If the graph is disconnected, an illegal argument exception is caught and we print the error message. It's like attempting an exploration from a point that isn't connected to the rest of the graph.